Welcome back. This is part 2. We are talking about AI agent patterns. We have a previous meeting that give us context about how the LLM work, how the assistant work, how to ingest like a knowledge base, and let's continue with the next topic here around the RAG pattern. So we have this mental map that I was creating. We show you in the latest part of the last conversation, we were talking about like a RAG pattern where we have a user who is using an assistant. We are sending a request. The request goes to a knowledge base, and the LLM finally create a response for us. So here we have like this same context, but within this context, in order to improve the capabilities of the assistant, we were creating like tools. This is one of the main features of the assistant. The assistant has like, typically they have tools because they are functions where we give us to the assistant new capabilities. For example, mathematical operations. We can add features to allow the assistant to go to the internet to look for some data. We can do integrations, creating like API calls, so the assistant can hit like an internal service, and they are just examples about capabilities of the assistant. These are like a pretty powerful approach, but it has some limitation, at least during our experience. Here we have some examples about how these prompts looks like. As a reminder here, these are prompts that we are showing that comes from Langsmith Hub, where we can have like multiple prompts, system prompts that we can use to create our assistants. And here let's review this React prompt. So here we have: answer the following question as best as you can, just output result, no comments, you have access to the following tools. And here we have a placeholder, so we can include the tools that we will create for the assistant. Probably they have a name and they have parameters, so the parameters they will need to run the tool. And then they define like an algorithm. Use the following format. So question, the input question you must answer. Thought, you should always think about what to do. Action, the action to take should be one of tool names. And the input to the action. Observation, the result of the action structurally. And this thought action input observation can repeat n times. Thought, I know the final answer, and the final answer is the final answer to original input question formatted in some format. So that final answer is the one that will come back to the user. Then we have, in part of the system prompt, we have the question, the user input questions, and the thoughts. Where were the thoughts the assistant used to arrive to our questions. So here we have a RAG assistant with tools in a single process, so the assistant has the responsibility to manage the tools, and they have an iteration looking for like what are the React means reasoning and action. So they evaluate what are the questions that they need to resolve in order to arrive to the final answer. So this process will live within the single assistant and within the single assistant process. When we were using these tools, I think it's something pretty good, but it has some limitations, because in the loop, maybe depends on how you configure, like you can arrive to an endless loop, or we can have to different responses, because the assistant is choosing one of the tools is using to create some data. So create some partial response in order to create like a end response. So if you are sending like the same question to the system, probably you can have like multiple responses, so it's not deterministic. And it has as well, if we have in an endless loop, and if we are calling like a private model, we will have to pay for all the invocations. So it is important to understand what we are doing, and as well to have like an observation layer, for example llama smith in LangChain context, so we are aware about what we are happening and where we have the bug. So I think that the main limit about this kind of implementation is that we don't have control about which tool will be used by the assistant, because the assistant is the one that will manage that logic. So what we have as another approach is to have like a multi-agent environment. So we have like multiple agents interacting between each other, and LLMs we will consume and use an LLM, and typically we'll have a supervisor or concierge assistant who is the one like is dispatching tasks to do between the agents. Here we have some schemas that I created for this presentation. So we have like a multi-agent environment, and I put like these two main groups. We have within a single process. Let's say this block represents a process. The process, it has like multiple agents. They work together in a graph where we have like some state, and this graph of course can have like multiple shapes. Typically they are a graph. They are a graph with an schema. Here we have, as in the previous patterns, we have our vector knowledge base, when we have the conversational knowledge base. I split it here because typically we are using different database, because here probably we can use Postgres with the vector extension, and for the conversational DB we want to have something faster, so we can use Redis. So the important part here is like we have a process that have a multi-agent environment that works together through a supervisor in a single state machine that will create and do something for us in a more deterministic way. Another approach is to have like multiple processes that they are independent, so we can have our agent in different processes, and the communication between the agent will be through messages. In this case, an example of this implementation could be LangGraph, where we have a graph or assistant graphs, or here agent graph, or here we can have like a llama index approach, where they created like a multi-agent environment where they have like this isolation between the agents that I think that at least they are interesting, because they are using common architecture pattern to split and to create like a more complex structure in a scalable way. So here we have a supervisor assistant, and the supervisor is delegating, this is just an example, is delegating tasks to the agent, then can run like multiple calls that the agent can work in parallel or in a sequence, and at the end will synthesize a final response to the user. The main difference is like we have a graph state machine where we are giving instructions to the assistant in a more detailed way, how the agent will work with their tools. Here in the graph state, we can have agents interacting with other agents, and the agent interacting with their tools, and we have like some conditional connection between them, so it's more deterministic in which way they will behave dependent on a task. So here we have some pattern in this context. where this comes from mainly from LangGraph and LlamaIndex, and these are just examples of how we can structure this agent. So in the LangGraph ecosystem, we have a user that interacts with a supervisor, and the supervisor will delegate some task to agent, depends on some criteria, and the conditional arrow between the supervisor and agent is represented by a root. Every time that we have a root, that is optional and depends on the state and some other logic. Here we have a supervisor that has agent. Here in this other approach we have a supervisor who has, and the teams have like agents. In this case we have a research team and document authoring, where we are doing a research, web scraping, writer, note taker, and chart generation. So we can create like a more complex structure in a more detailed way about how we want to our system to behave. And this is a custom multi-agent environment where we don't have like that hierarchy about a supervisor or teams. Here we have just a user, and we have two agents with the router, which represent like a conditional connections to one or the other agent with the tools. For example, and in this example we have a supervisor which has a research team and a paper writer team. So first the supervisor will do a research. They want to create some set papers, so first we'll create a research task to extract some data, and then we'll have another team that will be responsible to write the paper, and each team will have like different agents with their own tools in order to create their response. The other approach could be this one, where we have a LlamaIndex approach, where we have event-driven agent ecosystem. Here, let's see, we have a start event, and we have the concierge. And first of all, as you can see, these green balloons are the events. So they are the agents are decoupled from each other through events. And in this case, we have a concierge, which will be some equivalence with the supervisor. And in this case, it has an orchestrator as well, and the orchestrator has like three main capabilities. Is looking for stock options. They can transfer money and authenticate against a system to do the transfer, and as well it can extract like an account balance. So this is just an example about how this how can be an implementation through events. And this is like a more complex structure. In this example, we have here one of the heads in LlamaIndex, and here, as you can see, we have the assistant which is interacting with the user, and he's logged into an account, and he's populating with some data about the amount to transfer, transfer, and they log into a system, and they can here we have the options like look up for stock price, authenticate to your account, and check an account balance, and do the transfers. So in this case, we have a conversation through this multi-agent concierge, and that will help us to do different actions, and depends on what we want to do. We will be attended by one of these agents, like the one that transfer money, authenticate, or to look for the stocks. This other approach here, we have in the same context of LlamaIndex, we have a start event, and what we are evaluating a query. So if we have a bad query event, and we have an improved query state. And what is interesting to show here is once in order to improve the query, we need to evaluate evaluate the query. And we are doing here in 3 different ways. They are using like different approach or algorithm, and we have a step where we are evaluating like these 3 different responses in order to retrieve what is the improved query that the assistant will create. And this kind of behavior is called like reflection. So we are evaluating, once we have an answer or multiple answers, we are evaluating which one is the more accurate or with the highest score, and send it back to the user. And another pattern here that we will have, or features, when we are talking in the multi-agent environment, no matter if we are talking about LangGraph or Langsmith, we have the human in the loop behavior. So the human is part of the graph, of the agent graph process. So in this case, we are doing a research. The human review the research, and it evaluates if the research is good enough or not. So if the human say we will go through a loop until we feel comfortable with the result, and then we will write the report and end with the process. So in this multi-agent environment, we have this behavior named like human in the loop, and this is just an example about we have a conversation, and this example is just doing an example about a research. The human say, well, that information, it is like a Lorem ipsum response, but wants to show the mechanism. The human say no, that result is not accurate or not enough. So I'm doing some research about a topic, so it's getting to the loop, and then the human will confirm or not if the result is better. So this is in the context of the multi-agent environment. And then we arrive here to this other brand new change that we are doing. Here we have our building blocks to create assistants, and we have the user, we have a supervisor, and we have a multi-agent environment. We have our LLMs, we have private LLMs, we have public LLMs. We can have some customization with the LLMs in order to be more specific to our business model. And what we want to do here is to change our knowledge base. So instead of having like a knowledge base with embeddings, we will have a graph database, and this pattern is called like GraphRAG. So what is interesting to highlight in this approach, we have the user, we have the assistant. In this case, we have the LLM, and instead of having our knowledge base, we have a graph database in order to do the query. And in order to interact with the graph database, instead of doing a query that will be transformed to an embedding and retrieve like similarities documents to create an answer, we need to talk the same language that this graph database used to use, which we will need to create cipher queries. So in this process, in some way, the assistant needs to deal with the graph database with a cipher query. So the assistant, one of the first steps will be to create like a cipher query in order to retrieve information from our graph database. So we will do this call first, and then we will execute the cipher query against our graph database in order to retrieve information that we want to create a response. And something to highlight here is like the graph database will store our information, or like the business data could be in a medical context, could be a hospital, doctors, patients, and so on. And as well, we'll store the embeddings. We'll store our chunks, the documents, conversation in the same database. We will store everything. And then with that information, we will call the LLM, and with that information, we will create a response with some LLM. So the biggest change is in this layer. where and in the previous one when we want to create a query and interact and extract data from our graph database. So how does it looks? So we have a question, and the question will we need to do a transformation, so we need to request to the LLM so we can to translate this sentence to this cipher pattern. So in this case, let's see, we have let's say that the user asked what treatment has Dr. Smith provided to these patients. So in this case, the biggest change is the knowledge base. In the knowledge base, we know our domain. So in this case, we are asking about Dr. Smith treated patients who received treatments from him, and we are returning the patient name and treatment that was given. So no matter the example, is just I want to show you how does it looks. With this information, we will retrieve data from our knowledge base, and the knowledge base will be structured in two main subgraphs. Here we have how does it works. We will have this layer in the graph database where we have like a lexical graph and a domain graph. Depends on the sources. There are some differences overlapping between each other, but the main difference here is like we have the lexical graph that will have the documents, information that we provide to this graph database, and then in the domain graph, this is the data that will be extracted from our documents. These documents can be conversations, PDF, books, etc. So in some way we will have like two graphs that the first one will give like context, like lexical, what are the synonyms, where are the documents, where are the summary of the documents, where are the chunks documents we have, and the other graph, it has the data itself. In the example of the query, we will have the Dr. Smith node that is related to their patients. So in parallel, what we have is like the knowledge base in a graph structure, and we have as well our domain. So we can ask to the graph database in the same way that we are retrieving from our knowledge base, but against this context. And the benefits is here we know about how our domain is structured. So it's more domain specific, it's more powerful in like bigger context, so we can create the domain graph completely and extract and going through. We can ask like pretty detailed information to our graph database, and we will get the domain graph neighborhood where we have the doctors, the patient, treatment, for example, and we can have like in the lexical graph we can have the chunks where that information come from, where are the documents, where are the historical the medical history of the patient, and so on. The approach will be the same. We will have a question. The question needs to be encoded in cipher. Here we have a tool selection where what we want to have here is context. So we will query. We will do a query against our graph database in order to get like the context that will come from the lexical graph and the domain graph. In this example is an example of a domain graph. Comes from LangChain with text from Marie Curie, where Marie Curie in this graph domain, it has like this relationship with these other nodes, and it has awardee like a Nobel Prize. It was a professor in this university. It has this nationality, and their profession is physicist or chemist. So in the graph, we have our domain, and we can ask to the LLM in a very meaningful way. we can ask, for example, what is the profession of Marie Curie, and the knowledge base will do the query to extract this knowledge base, and then the domain will have a relations to the chunks where the information was extracted, so we can go in deeper and have like more context. So this is just some pretty small example that is to illustrate how this model domain graph looks like. And here we have a lexical graph where we have a document that was split in chunks. The chunks are part of the document, and as well there are some processes where we can extract entities from the chunks, and we can group the entities in communities, and we can create as well group of communities. This is like a structure that we will find in the lexical graph. So the biggest change here in this approach is that we will change the layer, how we are storing the information in our knowledge base with a graph, which has these two main components. And of course, as we can combine the approach. For example, we have a multi-agent environment where we have our supervisor or concierge that has like multiple agent, and the knowledge base will be a graph database. So in this case, we are using the latest approach with a multi-agent environment, and where we have like several techniques that, as we saw, we have reflection, we have tools, we have human in the loops, we have a way to give feedback to the multi-agent environment. And as we saw, we have like different approach in a way that we can implement it. Depends on the framework that we fits better for our needs. So this is the end. I hope you found interesting these different approach to create like the assistants. And since the AR world like is pretty extensive and pretty fast in the way that they are evolution. So at the beginning we have a user that interacts with an LLM. Then we saw as well, let's create an assistant that use the LLM, and we can provide like a detailed instructions. We can then add a private knowledge base, so we can extend the knowledge of the LLM, and we can provide tools to the assistant in a single process. We can have like a multi-agent environment in order to complete like more complex tasks, and we can change the knowledge base layer in order to use a graph database, where we can introduce like we can have a mix between the lexical graph and the domain graph in order to respond more accurately in bigger context. And we can combine how a multi-agent environment with a graph database. So hope you find this presentation useful, and let us know any comments or question. So we see it in the next one.